Hi guys, this is Geo Notes 1-1, our very first notes video. So anytime you are watching, you can pause, you can go back, try not to skip ahead too much. And by the end, you should have the majority of the notes filled out. We may leave one or two blank to do as a little recap the next day in class, if I'm seeing you that next day in class. So just kind of keep that in mind as you're moving through, all right? We start with vocabulary because before we can talk about really anything in geometry, we have to get down some of the basics of what the language is. So with this very first unit, that is where we start. You're going to see that you've got terms here. We've got the definitions already written in to save us some time. All we're going to be adding are diagrams and then if there's some notation. So the very first thing, a point. You know what a point is, but definition, a location in space, no particular size, or thickness to it. So go ahead and plot yourself just a little point, and then you can name it with a single letter. So, point P, point A, something along those lines. As for notation, there's no special notation. You'd literally write it out as point P, or that's how you'll see it as you're reading through different problems, and maybe you're going to have to draw the diagram yourself. The next one for a line, straight path, extends forever. You know what that looks like. So give yourself a line. I actually want you to give yourself two. Right? They could be horizontal or vertical, does not matter. The two ways in which you're going to see this. You might see 2 points plotted on the line. So I'm going to call those A and B. In that regard, we would refer to this as line AB, and we'd actually draw like a little line over the top of it. And that would be the notation that we would use. Mm-hmm. The other way that you might see it is occasionally it'll have just like maybe a little cursive letter next to it. So maybe the letter N. And then in that regard, it would be referred to as line N, right? In the, like the written paragraph or something, right? Keep in mind, line AB and line BA, same thing. Does not make a darn difference right there. Right? All right, the next thing. We've got line segments, right? Essentially, same thing. We're just going to add, or I guess take away, the arrows. So we just have a segment here. I'm going to put A and B on the end. And then the only difference with the notation is that you're going to draw it so that it's just a segment over the top, just the bar, no arrows there. All right, so those tiny details will make a difference. A ray, basically looking at half a line. So it starts at an endpoint and it extends forever in one direction. So if I call the endpoint A and then I'll put point B over here, right? Then when I write it as ray AB, I want to make sure it models the way it looks. So if the endpoint is over A and then the arrow goes past B, that's how it should look here. Now, very rarely would we do this, but if it was written as B and then A, you'd actually have to draw the arrow backwards to have it represented correctly. A little quirky, but a little fun fact. All right, for the next thing, opposite rays. So two rays sharing the same endpoint, and essentially they form a line together. So imagine you have a line going through. Here would be ray AB, like just what we saw. And then if I put C on the opposite side, then I could say that ray AB and ray AC, because remember, you have to write it, oops, let me zoom that out a little, sorry. AB and AC are opposite rays. All right, the next one, a plane is a two-dimensional surface. And so to draw it, you do your best here. We kind of draw it so it looks like a parallelogram almost. So think of a plane like a piece of paper that would extend forever. All right, so a flat surface, no thickness, keeps on going. So I'm going to draw it. So it looks like it's kind of like a piece of paper floating out there. Right? And so how we label it, there's two ways that it can be labeled. You need at least 3 points that would form essentially like a triangle. So like ABC, and this could be referred to as plane ABC. Or sometimes you're going to see like a really fancy, not really cursive, but almost like swirly letters. So it might be like R or something like this with lots of like flair to it. Right? And in that case, it would be referred to as plain R, kind of like that. Right? Something to keep in mind. These 3 points right here, must not be collinear. So the next term, points that lie in the same line. So A, B, and C cannot be on the same line together, right? So A, B, and C are not collinear. Right? Or you could say they're non-collinear, like the next thing. So to show the difference between collinear and non-collinear, see if I can zoom in a little bit here. There we go. Simply draw yourself a straight line and plot those points A, B, and C. Right? Whereas if they're non-collinear, then maybe you have a straight line, and then here's A and B, and then C would be somewhere else. Right? So that's the difference between them. There really is no notation that you need because you would just be talking about them as points. Collinear is not like an object. It's more, a property that the points have. So that is the first page. We got a little bit more to go, but I think some of the stuff on the second page should be super familiar. So at the top, we've got coplanar. So obviously if we have a plane being that flat surface, that's points that lie on that same plane. So to kind of show that, just draw that same like parallelogram looking shape and then, put a couple points on there. So like A and B, and then maybe put point C out here. Right? So the reason I want to show that, is that you could say that points A and B are coplanar. Point C is not. So sometimes it's helpful to see like, oh, all right, it's got to be on here, not floating out there. Next up are the terms that I think should probably be really familiar to you. Complementary, supplementary, and vertical. All right, for complementary angles, two angles whose sum is 90. And I always think, I had students when I taught summer school one year, years ago, that showed me if you draw the little stick here, there's the 90 right there. So I thought that was a fun little way to remember it. All right, diagram-wise, typically they're drawn adjacent to each other. So if you draw yourself a nice little right angle and then just split it into two parts, we could say like this is angle 1 and that's angle 2. Then we know that the measure of angle 1 plus the measure of angle 2 has to equal 90 degrees, right? So that little M stands for measure. And then if we're going to talk supplementary, they're adding up to 180 degrees. Again, you don't have to draw them adjacent or next to each other, but you could. And in that case, we would just simply draw a straight line, pick a point, and then slice from there. So we could say here's, angle 1, over here's angle 2. And then we would adjust this statement to say that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Easy, done. The last one, vertical angles. I don't know what you've heard about geometry, but you might have heard people mention that we would do proofs. This is a term that we will talk about a lot when we hit geometry proofs later on in the year. And what vertical angles are, is that's not supposed to be it's supposed to be the opposite. Whew, you could lose one of those E's. The opposite angles formed by two intersecting lines. So let's draw that. Give yourself two intersecting lines. Basically draw like an X shape here. And then the ones that are opposite or across from each other. So like the one at the top and the one at the bottom. I'm going to call this one 1 and call that one 2. And then there's the 2 on either side. So there's the one on the left. I'm going to put 2 stripes. The one on the right, put 2 stripes. And I'm going to call that angles 3 and 4. And the cool property about these is when they're opposite of each other like that, they are equal to each other. So add that little note here that vertical angles are equal in measure. Right? So that means the measure of angle 1 equals the measure of angle 2, and the measure of angle 3 equals the measure of angle 4. So if this is 30 degrees, so is that guy. So the rest of the note packet here, what we are looking at are some examples that use all the properties we just mentioned. So we went through them quickly. So if you need to, you can always flash back. But let's take a look. We're going to be given a setup. I want you to read through it and then draw a diagram that represents what's going on. So for this first one here, it says that we have two angles are complementary. Underline that vocab term right there. The second angle is 15 degrees less than twice the first angle. Find the measure of both angles. All right. Well, right off the bat, the fact that we have complementary, we know means angles that add to 90. So when I go to draw the diagram, because that's the first thing I want you to do, I'm going to draw them a 90-degree angle and then just kind of arbitrarily cut it into two parts. It doesn't really matter if they look equal or not equal. Don't stress about that piece of it. But together, they're 90. All right. It says the second angle is 15 degrees less than twice the first angle. So 15 degrees less, that's subtraction, than twice the first angle. Now, we don't have to do let statements, but back in Algebra 1, this is where we would have said, let x equal, the first angle, and then let something equal the second angle. Right? We can do that all in the diagram here. So I'm going to just let x be my first angle, and then 15 degrees less than twice the first angle would simply be 2 times that, and then minus 15. So that's going to be my second angle. Once you have those set up, then we can write an equation. So the equation should be using that relationship. So here we can say that 2x minus 15 plus this x right here, together, they have to be 90. So that's the idea of adding angle 1 and angle 2 together. Does it matter what order we add them in? Nope, not at all. That's called the commutative property. All right, from here, clean it up. So 2x and x, we get 3x minus 15, and then keep on working to get that x alone. So add it over. This should give us 105 divided by 3. X is going to come out as 35. Does it have to come out evenly to a nice whole number? No, it works out nicely that it does. But keep in mind, if it came out as a decimal, that's perfectly fine too. All right. When you think you're finished, last thing, go back and skim the question again and figure out, did we actually answer it? So they're complementary. This tells us about the measures. Find the measure of both angles. All right, well, x is this angle. So this guy's 35 degrees. But we have to find the other one. So now if we do 2 times 35 and then subtract 15, that would be 70 minus 15. That'll leave us with 55. And that makes sense because together, those two would be 90. Done. All right. The next one, we're going to talk a lot later in the year about ratios and things, but this one should be kind of simple enough that you can draw from what you know in Algebra 1. It's saying we have two supplementary angles in a ratio of 3 to 5. Find the measure of both angles. All right. So supplementary right there. There's 180, which is going to help me with my diagram. So when I draw it, I'm going to draw it the way that we did in our notes up above. Something along those lines. Don't worry, if you want a straight edge, great. If not, not a big deal. The ratio part. So that means that if I reduce them to lowest terms, they're in a ratio of 3 to 5. They're not actually 3 degrees and 5 degrees themselves. So what I want to do is I want to take each piece of that ratio and multiply it by x. So we're really going to treat it as 3x to 5x. So I'll make my smaller angle 3x and then my larger angle 5x just to make my diagram make sense. From here now we can create our equation. So the equation, if they're supplementary, is that 5x plus 3x should equal 180 degrees. That's going to give us 8x equals 180 divided by 8. X comes out to be 22.5. Again, this one asks us to find the measure of both angles. So we have to do a little work to get both of these. So 3 times 22.5 and 5 times 22.5. the smaller of which is going to be 67.5 degrees. The larger of which is going to come out to be 112.5 degrees. Of course, use your calculator when you need to. Even a phone calculator would get that done just fine. All right. Last page of the notes. We're going to hop around just a little bit. So flip it on over here. This next one hits a concept that I said we would see a lot in our proofs in the future. So when it says angles A, B, D, and angle E, B, C. So when you trace it out, A, B, D is this angle. E, B, C, that's this guy here. Right? Those are vertical angles. When it says find the measure of angle ABD, well, of course, we need to set up an equation. So we've got the diagram, check. So the equation is we want to use the relationship that we wrote in the notes on the last page, and that's that vertical angles are equal to each other. So set these guys equal. So 5x minus 5 equals 3x plus 15. And then start moving some things around. I'm going to subtract 3x, and to save some time, I'm going to add 5 at the same time. So this will give me 2x over here. This will give me 20 over here. X comes out to be 10. But that's not my answer. I want the measure of angle ABD. So I'm going to plug back in. So to get the measure of angle ABD, I'm going to do 5 times 10 minus 5. And then that should come out to be 50 minus 5, or 45 degrees. So in the picture, this is 45, and then its vertical angle has to be 45 as well. All right, last part, measure of angle ABE. ABE is this guy up here. So in this case, what we have to think about is what other relationship do we know here? What I want you to look at, and there's a couple ways to look at it, but we've got this nice straight line here. And if this is a straight line, then this whole angle measurement should be 180. We've got supplementary angles. So if we use the idea that they are supplementary, then we can find that last angle measure. All right, so go ahead and calculate this guy here. All right, the last ones, 4 and 5 at the bottom, says find the complement, and find the supplement. I'm trying to say both of those at the same time. All right, with these, we don't have to set up a full equation. So when it says the complement, that's code for, we're talking about complementary angles. So if I know that one of the angles is 28, I can call this x, and I could set up an equation to say x plus 28 equals 90, and then subtract. Or what some of you might have already been doing was just saying, I don't need to label it x. I can go right to 90 minus 28 equals my answer over here. So try that for the last one. The only difference is it's asking you for the supplement of 67. So you can set up the visual if that helps. Or I want you to think about how can you go right from knowing what supplementary angles means and this angle to figuring out this last one right here. All right, when you are finished with the video, make sure to answer the questions on the Google Classroom. I'm going to hint and tell you right now that they pertain to these two that we didn't fully answer together, and then we'll talk more about it in class next time I see you. Thanks, guys. Have a good one.